we are going to discuss the transformation of quadratic functions to their vertex form. The vertex form of a quadratic function is written as f of x or y is equal to a multiplied to the square of the difference of x and h plus k. When the quadratic function is written in this form, the vertex h and k can easily be identified without using the formulas. To transform the standard form to vertex form, the process involves a technique called completing the square. So how are you going to transform a quadratic function to its vertex form when a is equal to 1? Let's have this example. Y equals x squared plus 4x minus 5. Our a is equal to 1. If the expression ax squared plus bx plus c is not a perfect square trinomial, then use the completing the square. Since x squared plus 4x minus 5 is not a perfect square trinomial, then we will use the completing the square. Our equation is now written as y equals x squared plus 4x plus blank minus 5 minus blank. For us to know the number that we are going to add and subtract, we are going to use the formula square of the quotient of b and 2. That is now equal to the square of the quotient of the value of b, which is equal to positive 4, and 2. 4 divided by 2 is equal to 2. If we will get the square of 2, that is equal to positive 4. So the number that we are going to add and subtract is 4. We now write x squared plus 4x plus 4 in its factored form. The square root of x squared is x. Then we copy the sign of our middle term. Square root of 4 is equal to 2. We now place our grouping symbol and its exponent, which is 2. Negative 5, combine it to negative 4, is equal to negative 9. The vertex form of the given quadratic function is y equals the square of the sum of x and 2 minus 9. We can now identify the values of h and k. H is equal to the opposite of positive 2, which is equal to negative 2. And k is equal to negative 9. Now, how are we going to transform quadratic function to its vertex form when a is not equal to 1? We try this example. Y equals 2x squared minus 3x minus 2. If the expression ax squared plus bx plus c is not a perfect square trinomial, then use the completing the square. Since 2x squared minus 3x minus 2 is not a perfect square trinomial, then we will use the completing the square. First, we are going to group the quadratic term and linear term together. So we have y equals the difference of 2x squared and 3x minus 2. Next, we factor out a, which is positive 2. So y is equal to 2 times the difference of x squared minus 3 over 2x. Then copy minus 2. If a is not equal to 1, this is how we are going to write our equation. Y equals 2 times the quantity of x squared minus 3 halves of x plus blank minus blank. Then we are going to subtract 2. To find the missing number, we are going to use the formula, the square of the quotient of b and 2. So that is equal to the square of the value of our b, which is negative 3 over 2. Then we will divide it by 2. We first simplify negative 3 over 2 divided by 2. And the answer is equal to negative 3 over 4. Then don't forget our exponent, which is 2. If we will get the square of negative 3 over 4, that is equal to positive 9 over 16. So the number that we are going to add and subtract will be 9 over 16. We now write x squared minus 3 halves of x plus 9 over 16 to its factored form. So that is written as the square of the difference of x and 3/4. We now copy y equals 2. Then we need to use another quantity. We copy minus 9 over 16 and also our minus 2. We now distribute 2 to the terms in our quantity. So 2 times the square of the difference of x and 3/4 is written as 2 times the square of the difference of x and 3/4. And 2 times negative 9 over 16 is equal to negative 9 over 8. And don't forget to copy minus 2. Now let's combine similar terms. So negative 9 over 8 minus 2 is equal to negative 25 over 8. Then we copy y equals the square of the difference of x and 3/4. So this is the vertex form of our given function. With this, we can now identify the values of h and k. For the value of h, we simply get the opposite of negative 3/4. So h is equal to positive 3/4. For our k, it is equal to negative 25 over 8.